Hi friends, welcome to our channel. In this video, we will do problems on while loop. Okay, let's have a look here. The first problem is find the factorial of a number by using while loop. Okay, first, what is the factorial? Okay, what is the factorial? Okay, let's have a look here. First factorial means the factorial is indicating with exclamation mark. Okay, exclamation mark. Simply I'll say suppose 1 factorial. Okay, 1 factorial is equal to 1. Okay, 1 factorial is equal 1. Next, suppose 2 factorial. Okay, 2 factorial means 1 into 2. Okay, 1 into 2 is equal to 2. This is the 2 factorial. Okay, 1 factorial means 1. 2 factorial means first number into second number. Okay, first number into second number. Suppose 3 factorial means 1 into 2 into 3. Okay, that means 1 2s are 2, 2 3s are 6. This is the 3 factorial. Okay, 3 factorial. See, now 4 factorial means 1 into 2 into 3 into 4. This is the 4 factorial. That means suppose if you want to find any number of a factorial, you have to multiply the before numbers of multiplied with the before numbers of that factorial numbers. Okay, before numbers, the multiplication of a numbers from 1 to whatever number he is asking factorial up to that number. Okay, up to that number. See, suppose now I want, see, 1 2s are 2, 2 3s are 6, 6 4s are, okay, 24. Suppose I want 10 factorial. For an example, I want 10 factorial means, okay, 10 factorial means 1 into up to 1 into 2 into 3 into 4 into, okay, 5 into up to, that means 1 to up to continuously, 5 into up to 10. Okay, up to 10. In this way we have to calculate, this is the factorial of a number. Okay, this is the factorial of a number. I hope you understand. Factorial of a number means the multiplication of a number from 1 to that particular number. Okay, the multiplication of a number to that particular number. Okay, this is one point. And another point is, suppose if you want to find the 10 factorial means 10 factorial is equal to 9 factorial into 10. Okay, 9 factorial into 10. Suppose if you want to 9 factorial means 8 factorial into 9. Okay, you have to multiply before number factorial into that particular number. Okay, it's updating continuously. Okay, it's updating continuously. For an example, simply see, by using this condition only, you will prepare a problem, you will prepare a program. I'm sorry. Now see here, this is 1 factorial into 2. Okay, this is 2 factorial into 3. This is 4 factorial into this is 3 factorial into 4. In this way we have to calculate the factorial. Okay, that means the multiplication means the initialization of a multiplication is 1. Okay, now we will do problems. First I am taking one number. Okay, that number I don't know. Oh, suppose simply I am taking user input later. I am taking one random number. Okay, here I am taking number is equal to 5. Okay, number is equal to 5. Factorial I am indicating with a simply shortcut word fact. Okay, I am initializing with 1. Okay, why? Because when we are doing a multiplication, the initialization always be 1. Suppose the initializing 0 means the complete multiplication will become 0. That's why the initializing of your multiplication is 1. That's why here the factorial I am initializing 1. Okay, next, counter variable. Okay, counter variable I is equal to 1 I am taking. Okay, counter variable I is equal to 1 I am taking. Why? Because the factorial is always starts from the 1. Okay, counter variable I is equal to 1 I am taking. Okay, now see, apply the while condition. Apply the while condition means the numbers is always starting from the 1. Looping means first number onwards it will start. That's why I is less than or is equal to 5. Okay, here we need to find the factorial up to 5. Okay, we need to find the factorial up to 5. I hope up to here you understand. Okay, the looping is starts from first. Okay, I okay, the initialization of I is equal to 1. That's why one is I is less than or is equal to y. The loop up to five loops it will be print. Okay, now see initialization factorial. Okay, initialization factorial is equal to 1. The factorial is equal to 1 is equal to fact into, okay, fact into I. Okay, fact into I. Okay, see the for first loop I am explaining. For first loop means what is the first initialization number? 1 into, here fact is equal to how much? 1. Okay, here factorial, in factorial variable, how what is the value will be stored? 1 into 1. Okay, 1 into 1 it will be 1. For first loop factorial 1 will be stored. That means the factorial of 1 is 1. The factorial of 1 is 1. Now the factorial of 1 is 1. Okay, now initialize. Okay, already loop already, in previous video I told you, right? The increment variable. Okay, here the value will be incremented. Okay, one loop after another loop it will be incremented automatically. That's why the initialization of incremented is equal to I is equal to I plus 1. Okay, I is equal to I plus 1. For shortcut for this, I plus is equal to, okay, compound assignment operator. Okay, compound assignment operator, that means I is equal, okay, I is equal plus is equal to 1. Okay, in this way for next problem onwards I will implement that. Okay, this is the program. Okay, now I need to print output to print fact. Okay, print fact. But internally what happened I will explain you clearly. Now here 5 loops it will continue. Okay, here up to 5 loops. In first loop factorial of 1 is 1. Now the factorial value is 1. Okay, now factorial value is 1. In second loop what happened? Okay, in second loop factorial is 1 into, factorial is 1 into I is equal to how much? In second loop I is equal to 2. That's why the value is equal to 2. Okay, in second loop I is equal to 2. The value will be 2. In the third loop what happened? In third loop, now the I value, now the factorial value is 2. Now the factorial value is 2. In third loop what happened? Already now in third loop means before 2 factorial into 3, 2 factorial into 3. In third loop means 2 into 2 factorial of 2 is 2 into I value how much now? 3. Now the value is 6. This is the 3 factorial. Okay, this is the 3 factorial. Now fourth loop. Okay, now fourth loop what happened? Now fourth loop. Okay, fourth loop means we have to 3 factorial into 4. Okay, 3 factorial how much? 6. Now factorial value is 6 into 4. Now it is 24. Okay, in fifth loop what happened? In fifth loop, fourth factorial. Okay, 4 factorial means 4 factorial 24 into fifth loop 5. Okay, is equal to 120. In this way it will be print. Okay, I hope now see the output. Now what is the value? The value is 120. The value is 120. Now here I am giving user input. The number is equal to int number input. Enter the number. Okay, enter the number. Now see, now I am finding one by one. Now 1 factorial. Suppose here I am giving 1. 1 factorial how much? Okay, here also, sorry, here I need to change now. Okay, now see. Now see output. Now 1 factorial how much? 1 factorial is 1. Okay, 1 factorial is 1. Now suppose I am giving 2 factorial means how much? 2 factorial means 2. Okay, suppose now I am giving 10 factorial. Okay, 10 factorial means how much? This is the 10 factorial number. Okay, in this way we have to do the factorial by using while loop. Okay, same condition we will apply for loop. Okay, but there is no counter variable in for loop. Okay, it's a small difference. Okay, I hope you understand this problem, friends. Next, we will dive into another problem. Now, see the second problem. See, friends, reverse a number. Okay, these all are basic level problems. When we are learning any programming language, we have to learn these type of problems are must. Okay, here that means reverse a number, counting numbers, okay, counting strings, part of strings, okay, factorial of a numbers, Fibonacci numbers, palindrome programs, patterns printing. These type of problems are very must when we are a beginner. Okay, then there is no way to skip. Why? Because we have to. This is the initial level. You will learn this type of small problems. When you will become a professional at that time, you will crack the whatever logic as per the client requirement. It will be easy to you. Okay, okay, now see, now problem is reverse a number. Okay, here reverse a number means, already see example here, 123 is a given number, reverse means 321. Okay, you have to print this. First I will try with this only. Now here I am taking number is equal to 123. Okay, here number is equal to 123. Here what he is asking, reverse number he is asking. Okay, that's why reverse I don't know. That's why initially I am initializing with 0. Okay, initializing with 0. See, in this problem, we don't want to give any counter variable. Okay, here counter variable is a optional in while loop. Okay, not must. Here you don't want to give any counter variable in this program. Why? Because here the number will be act as a counter variable in this problem. Okay, I'll show you problem. See here, reverse is equal to 0. Now I am applying while loop. Okay, the number is greater than 0. Okay, here the number is greater than 0. If the given number is always greater than 0, then the condition is, you see here, now when you are going to inside, here what he is asking, reverse he is asking means you have to print one digit by one digit. Okay, one digit by one digit. That's why first I want one digit. Okay, what is that digit? Okay, what is that digit? Here 123 is the given number. Reverse means what you have to print first? 3 will be print. Okay, 3 will be printed. That's why I need to separate 3 from the complete number. Okay, I need to separate 3 from the complete number. Now see, 123, that means number percentile 10. Okay, number percentile 10 means what happened? Okay, number percentile 10 means when now 123 is dividing with, okay, 123 is dividing with 10, 120, okay, in 10 table 123 is not going, 120 is going, then the remainder will becomes 3. Okay, then the remainder will becomes 3. Now what happened in reverse digit? Take reverse is equal to reverse. Okay, take reverse is equal to reverse into 10 plus digit. Okay, okay, here what happened? See, I hope up to here you understand. Okay, here I did separation the digit from the complete number. Here I did, here remainder is 3. Okay, remainder is 3 means when we are using percentile operator, the remainder will be print. Okay, the remainder will be print. Now the digit is how much? Now the digit is 3. Now the digit is 3 means in the next statement what happened? In a digit place it will be print 3. Okay, in a digit place it will be print 3. Now here reverse means initially the initialization of 0 is equal to the initialization of reverse is what? 0. 0 into 10. Okay, 0 into 10, 0. Okay, 0 plus 3, 0. Here 0 will be print in first loop. Okay, first loop 0 will be sorry, in first loop 3 will be print. Okay, 3 will be print in first loop. Now what happened? Now see, already 3 printed. Okay, now 3 printed, already 3 printed means next what are there? 1 2 are there. I need to, for next cycle in a number place I want only 12. Okay, in a number place I want only 12. Now that's why here I am using floor division. Okay, floor division means num is equal to num double okay, double forward slashes, okay, double forward slashes by 10. Okay, here what happened? Now here division. Now 10 means 123 is divided by 10. Here quotient will be print. Okay, here quotient will be print. Here quotient is equal to how much? 12. Okay, here quotient is equal, here remainder printed, right? Here quotient will be print. Here quotient is 12. Okay, now in a number place quotient will be print. Okay, now loop again start from first onwards. Okay, loop again will start from first onwards. At that time, what is the number? At that time, what is the number? 12. 12 is greater than 0. The condition becomes true. Okay, the condition becomes true. Now, here up to now, okay, up to now, what is the output? Up to now, 3 printed. Okay, up to now, 3 printed. Okay, next. Now number is 12. I hope up to here you understand. Now number is 12. In a number place, 12 will be printed. Okay, in a number place, 12 will be printed. 12 divided by 10 means the remainder will becomes 2. Okay, the remainder will becomes 2. In second loop, okay, in second loop, 2 will be printed. Okay, the second loop, how much will be printed? See here. Okay, now the reverse is equal to, see how much previous digit 3 in a reverse place, digit 3, that's why reverse is equal to 3. Now here 3 into 10. Okay, 3 into 10, 30. 30 plus digit how much? 2. Okay, digit how much? 2. Now 32 will be printed. Now 32 will be printed. Okay, now 32 will be printed in this place. In second loop, 32 printed. Okay, now the number is 12 divided by 10. Okay, 12 floor division 10 means the quotient will be 1. Okay, the quotient will be 1. Now 1 percentile 10 means how much? Okay, 1 percentile 10 means how much? The remainder will becomes 1. Okay, the remainder will becomes 1. Here already 32. 32 into 10. Okay, 32 into 10 plus 1. Here digit place how much will be print? 1. 321. Now 321 will be print. Okay, 321 will be print. Now, okay, in third loop what happened? In third loop, 3 in reverse place, 321 will be printed. Now there is a number. Now condition becomes false. Up to 321 will be printed. Now see what is the output? Print reverse is equal to, okay, print reverse. Now what is the output? See, the output is 321. Okay, the output is 321. I hope you understand this concept. Now this number I'll check with user input. Okay, input, enter a number. Okay, your wish. Okay, enter a number. Now your wish. See, I am giving random numbers. See, this number I am given. What is the last number? 5. What is the last before number 7? Okay, now see the output. See the last number. 5, 7, 8, 6, 7, 8. See, this is the reverse number. In this way the program will be executed. Okay, I hope you understand, friends. Okay, but when we are doing with our upcoming for going forward, we no need to do in this way. We have shortcut methods are there. Okay, we have so many shortcut methods are there. Actually this program we will execute in single line. Okay, yeah, by using string slicing. Yeah, this program will execute in single line, but we will do in upcoming classes. Okay, thank you, friends. Next we will dive into another problem. Friends, now we will do the third problem. See, check whether a number is a Armstrong number or not. First, what is the meaning of Armstrong number? Okay, see, for an example, Armstrong number means if you take any number. Okay, for an example, here I am taking 1. 1 is a number. Okay, 1 is a number, whatever, maybe digit is also okay. Okay, if here 1 is a number, what is the length of the number? The length of the number is also 1. Okay, the length of the number is also 1. That means 1 is equal to 1 power 1. Okay, 1 is equal to 1 power 1. How much? Answer is also 1. Okay, I think you are not understand this point. Now I am taking 2. Okay, now I am taking 2. Okay, suppose what is the 2 is equal to, 2 is equal to The length of the 2 is also 1. Okay, that means 2 is equal to 2 power 1. Both are same means at that time it's a Armstrong number. Okay, I'll show more example. Here I am taking 153. Okay, here I am taking 153. See, 153 means here the total 153 is equal will becomes like this, means that means the number of digits how many. First, what is the length of the number is equal to how much? The length of the number is equal to 3. Okay, here length means what? The number of digits in the complete number. Okay, the number of digits in the complete number is called length. Here length is equal to how much? 3 is there. Okay, that means the number of digits are 3. Okay, length is equal to 3. This is the first point. Next, that means here 1 power, okay, 1 power 3 plus 5 power 3 plus 3 power 3, okay, will becomes same number. Okay, that means 1 power 1 is equal to how much? 1 power 1 is equal to 1 plus 5 power 3 means how much? 5 5s are 25, 25 5s are 125. Okay, plus 3 power 3 means 3 3s are 9, 9 3s are 27. Okay, now you add this 125 plus 1 126, 126 plus 27 153. See, the power, the, okay, the sum of the powers of the individual digits. Okay, here in power place, here we include length. The sum of the powers of lengths will becomes same number, that's a Armstrong number. Okay, I hope you understand little bit. Here what I mean, the digit, okay, in power place you will keep length. Okay, the digit you will keep in power place length. The digit power of length plus the sum of digits power of lengths will becomes the same number. It is called as a Armstrong number. Okay, this is suppose here one more number is there for an example. Okay, now the what is the length of the number? The length of the number is 4. Now 1 power 4, 5 power 4 plus 3 power 4 plus, now we will add one more plus 4 power 4. Okay, 4 power 4. Now when we are doing this calculation, the answer will becomes the same number. At that number we are called as a Armstrong number. Okay, at that time that number we are called as a Armstrong number. I hope you little bit understand. Okay, now see the problem. Now see the problem. Here we need, okay, here we need some points. First, I will write a program with one random number. Then after I will give user input. Okay, here number I am giving as 153. Okay, number I am giving as 153. First, you have to prepare power. Okay, here we need power. That's why power is equal to, but power before, here power means length. Okay, here you need length. Length is equal to, okay, the len method not working for integers. Okay, the len method not working for integer. The len method is working for integers. I'm so sorry, len method is not working for integers. The len method is working for strings only. Okay, that means len of, suppose here you don't want to enter directly variable name. First, change the type conversion. Okay, change the type conversion, then after you will do. Now what is the length? See, the length is equal to, okay, the length is equal to 3. Okay, here what is the length? The length is equal to 3. Here this length we are called as a power. Okay, this length we are taking as a power of the digit. Okay, here this length we are taking as a power of the digit. Please keep in mind. Okay, that's why the variable name here I am changing as a power. Okay, here the variable name I am changing as a power. Okay, this is the first point. Here see, the number we changed into string, right? The number we are changing into string. That's why this number I want to change I want to store in another variable. Okay, this number I want to change in another variable. That is the temporary variable is called number. Okay, this the given number I need to store in another variable. Okay, that is temporary variable only. Okay, next, when when we are doing addition or subtraction, sorry, addition or multiplication, this type of problems, we have initializing with some random number. Okay, see, the sum is always initializing with 0. Okay, the sum is always initializing with 0. uh, Armstrong, for simply I am saying what is a Armstrong number definition. Okay, Armstrong number is equal, Armstrong number means, okay, Armstrong number means number is equal to, okay, the number is equal to sum of digits of the power of length. Okay, the sum of digits of the power of length. Okay, I'll show practically. Okay, sum is equal 0. Okay, up to here I hope you understand. Next, take while. Okay, already in reverse previous problem already we did in that way, all same in that way we have to do this problem, but a little bit small variations. Okay, while here also take here you don't want to take as a number, already number we stored in temporary variable, right? That's why here you take temp is greater than 0. Okay, temporary variable is greater than 0. Now here first we need digit. Okay, digit means what? Digit already told you, right? Temporary variable percentile 10. Okay, temporary variable percentile 10. Now the digit will separate, that means 153 divided by 10 means the digit will how much in first cycle? First cycle digit is 3. Okay, the first cycle digit is 3. Okay, next sum means sum is equal to sum plus, initially the sum is equal to 0 plus what is the first digit power. Power is equal to how much? Power only. Okay, power means length here. Okay, power means length here. According to this problem, here power place 3 will be stored. Okay, here digit means how much? 3. 3 power 3, 27 will be stored in sum place. First 27 will be stored. Next, temporary. Okay, temp is equal to, next suppose one digit we separated means the remaining number we have to cycle. Okay, then the loop will come in second loop, it will take as only 15. Okay, temp, okay, floor division 10. Okay, temp floor division 10. Up to here what happened in first cycle? Okay, in first cycle here what happened means in some place it will stay first cycle 27. Okay, first cycle 27. Okay, and second cycle, okay, second cycle 27 plus 27 plus 125 will be print. Okay, in third cycle 1 will be print. Okay, in third cycle, in second cycle it will print like this. In third cycle 27 plus 125 plus 1 will be print. Okay, when you are adding this number 153 will be come. Okay, now see the output here, the sum. Okay, first print the sum, print sum, how much will come? 153 came. Okay, 153 came. That means it's a Armstrong number. Okay, but it's a Armstrong number. We'll print in other way. If sum is equal to, okay, here sum is equal to temp. Already number we stored in temp, right? Is equal to temp. Print, it's a Armstrong Armstrong number. Okay, then else it's not a it's not a Armstrong number. Okay, in this way you have to do the problem. Now see the output. It's not a Armstrong number, it's printed. What did I mistake? Actually 153 is a Armstrong number. Okay, 153 is a Armstrong number. Why it came like this? In temper, sum is equal to temp. It's you print as num, I think. Yes. See, it's a Armstrong number. Here if condition I took as wrong. The temporary variable here already the work operations completed on temp. Now the now finally the temp is 0. Okay, finally the temp is 0, but initially the number is 153, right? Now the sum will becomes number. Okay, the sum will becomes number. It's a Armstrong number. Okay, now it's a Armstrong number. Now I'll give another number. Now I'll give another number. I will first here I need to change as user input, enter a number. Okay, enter a number. See what is the output. First here I am giving randomly 153. 153 is a Armstrong number. Okay, it's a Armstrong number. So next I'll give one more number, as well as 370. Yes, 370 is a Armstrong number. Okay, now I'll give any 400. Okay, 400 is not a Armstrong number. Okay, in this way we have to do the problems. Okay, I hope you understand, friends. This is the this is the printing Armstrong number by using while loop. Okay, I hope you understand. Next, let's dive into another problem. Hi friends, now see the fourth problem. Okay, count the number of digits in the given number. Okay, count the number of digits in the given number. First I will do with random number. Okay, here I am taking as a number. Okay, number here I am taking 567. Okay, now what he is asking, count the digits. Okay, count the digits in the given number. That's why here you no need to apply any other operations. Okay, previous we did Armstrong number as well as reverse numbers we did, right? You here you no need to do in that way. Okay, see, take count as the initial variable is 0. Okay, here count is equal to 0. Now here the temp, okay, the number you have to store, the temporary variable you have to, the number you have to store in a temporary variable. Now see, while temp is greater than 0. Okay, temp you greater than 0 already we did in this way. Now the temp apply for division. Now temp is equal to temp by 10. Okay, temp is equal to temp by 10. Here you apply for division. Now count is equal to count plus 1. Okay, now take print count. Okay, print count. See, I will explain this problem practically. Now number is equal to 567. Okay, the initial variable of count is equal to 0. This number I stored in temporary variable. Okay, this number I stored in temporary. Now the temp, okay, temporary variable is greater than 0. Okay, the condition is true. Okay, the temporary variable is greater than 0, that means 567 is greater than 0, the condition is true. Then that's why the temporary variable 567 floor division 10 means what is the coefficient at the time? 56. Okay, the coefficient for this is 56 in first cycle. Okay, in first cycle already here up to here the first cycle completed. Okay, first cycle completed. First cycle completed means in count variable one will be print. Okay, now once one will be print, that means count is equal to 1 here. Okay, count is equal to 1 here. Now up to here, okay, in first cycle is 567. Okay, when it will becomes second cycle, the temporary variable is 56. Okay, in second way, in second cycle the temporary variable is 56. Okay, now in 56 means now it will here it will be print 2. Okay, next 5 it will be print 3. Okay, now see, what is the output. Here 567 means how many digits are there? 3 digits are there. Then the count is equal to 3. Okay, then the count is equal 3. Suppose Instead of constant, I'll give user input int input, enter a number. Okay, enter a number. Now you here you see I am giving random number only. See here how many digits are there? 6 are there. See what is the output? 6. Okay, what is the output? 6. Now I'll give any big number. Okay, how many digits in this number? I also don't know. Okay, now see what is the output? 34 digits are there. Okay, 34 digits are there. In this way you have to do this problem. Okay, I hope you understand, friends. Now let's dive into another problem. Friends, now we see the fifth problem. Check palindrome. Okay, but here the palindrome I am checking with number only. Upcoming videos I will check with the strings and I'll show you shortcuts also. See here, friends. Here I am taking a number. Okay, here I am taking 101 is a number. Okay, you if you read this number, both sides it will read as one. Okay, 101. Okay, now see this number I will store in temporary variable as a number. Okay, next first I will do reverse. Okay, reverse is equal to 0. Okay, reverse is already reverse a number already we did in this video only. Second problem same as it is same problem, but here we check with palindrome. Okay, now see while temp is greater than 0, next first take as digit. Okay, take as digit means temporary variable percentile 10. Okay, now the digit will be print. Okay, digit will be print. Now the reverse, see reverse is equal to reverse into 10 plus digit. Okay, now that temporary variable temp percentile is equal, floor division is equal 10. Okay, now see what is the output. If if the output to see the reverse number, reverse is equal to num, the reverse is equal to num, print it's a palindrome. Okay, it's a palindrome. The remaining all cases it's not palindrome. Okay, now see. Okay, now see the output. It's a palindrome. Okay, it's a palindrome. Why? Because 101 you have to read any side. It's a palindrome. Okay, now I'll check with user input int input, enter a number. Okay, enter a number. Now see the output. Here I am giving 202. Okay, 202, it's a palindrome. Okay, it's a palindrome. Suppose I'll give 1000. Okay, I'll give 1000. It's not a palindrome. Okay, it's not palindrome. Okay, in this way you have to do the problems. Okay, I think easily understand already. In reverse the number already we see the explanation. Okay, the first digit is whatever the first digit is last digit. Okay, reverse it will be print, from backside onwards it will be print. The given number is equal to reverse number means it's a palindrome. Okay, I hope you understand, friends. Okay, up to here we did 5 problems on while loop. Okay, that's it on while loop, friends. In next video we'll do on for loop. Okay, I hope you understand. Please, if you understand, please like this video and share to your friends, and as well as subscribe my channel and press on the bell icon. Okay, thank you so much, friends.